Video is on. There we go. Okay, can I hear some of the predictions that we think are going to happen for case 1, 2, and 3?
1 and 3 are going to bounce back.
So, okay, I'm actually going to, should I write them? No, I'm not going to write them, but 1 and 3 are going to bounce back. So they're going to hit and just kind of bounce back. Okay, awesome.
Like we said that too, but I also said that they could like maybe cancel each other out between like of the same energy coming at each other.
Yeah, okay, really good thought. I like the words you use too, like some of the same energy coming together. Good stuff. What about over on this side of the room? What do we think? Yeah, awesome.
They're gonna hit and then come up and go down.
Woohoo! I like where you're going. Okay. Any other predictions before we get into it and look at it?
Same.
Yeah, Jacqueline?
Like kind of exactly when we did the Slinky lab.
Yeah.
Like the one person took one side and the other side and you like go. Kind of like wrong. He said then you come up and then go back down.
Yeah, do you know what? That was an amazing connection. That was awesome. I like that. You're right. And you're on the right page too. I like all the suggestions. So let's actually look at it over here. When we have two waves come together like this, what actually happens is we create a super wave, is what it's called, okay? So the amplitude of this wave and the amplitude of this wave combine to make like one huge wave right in the middle. So when they hit, it'll be double the size. It would look something like that. It'd be double the size. They'd mix together in the middle and come back down. Has anybody ever been, you know when you're tubing and you like bring your boat in like a circle a whole bunch of times and you just create, like you create a big wave. What happens is you're sending your weight all around in a circle, so right in the middle when those waves come together, they form one huge wave or a whole bunch of huge waves right in the middle, okay? So that's exactly what's happening here. You come around so that you have two waves coming together on each side, create huge waves that you can tube in. And then they right, exactly. So once they come up here, this one will just keep going this way, it'll fall back down, and they'll continue as the same amplitude as they were before. Okay? So they're just joining together, they're not losing any amplitude or any energy, and they just continue on. We'll look at an example. Don't stress too much about that. So what about the case with number 2 then? If these two waves come together to make a huge super wave, then what do we think is going to happen for question number 2? Yeah, Al?
They're gonna make a smaller wave.
Yeah, exactly. So since we've got one with a positive amplitude, one with a negative amplitude, when these two waves come together, you said a smaller wave. If these two are the exact same amplitude, we're going to get no wave at all. There's going to be nothing. And
So that's the one that counts.
Exactly. So when we talk about noise canceling headphones, this is the type of thing that we're talking about. They utilize this. They cancel out sound waves by sending other sound waves to cancel them out. Does that kind of make sense?
Yeah.
Okay. And then let's quickly look at the last one, number 3. What do we think is going to happen there then?
Superwave.
What's that?
Superwave.
Superwave again, yeah. So it's the exact same as the positive amplitude, it's just on the negative side now. So it doesn't matter where the amplitude is, if it's positive or negative, it's just they have to be on the same side to create that superwave. And then opposite side means that they're going to cancel out. So we can actually graph this and look at this mathematically. So I've just wrote up wave interference here. We call this one, you should actually write this down. Let's go constructive interference. That's this one and this one. That is when bigger waves are formed. Okay? Okay, so constructive interference. Let's think of a definition here. Let's say you can write what makes sense in your head, but what I would say it's when two waves of either both positive amplitude or both negative amplitude come together to create a super wave. That's what I would write for constructive interference. When two waves of either both positive amplitude or both negative amplitude come together to create a super wave. once you've got that written, I would also write destructive interference. So that's number 2 here. That's number 2's example. Basically, I would just write when 2 waves of opposite amplitudes come together to create a smaller wave.
I thought it made no
Destructive
wave.
interference. Or no wave. In this case, it was no wave, but can also happen with the resultant wave being smaller. Okay, awesome. Now we are going to look at what that would look like and actually like graphing that and looking at that mathematically, okay? So first case, I'm going to say this is, I'm going to get a different color. This will be the middle right here, or what Miss Ovia described as like the water level, okay? So if we have a wave that looks like this, I'm gonna go. And we join it up with a wave that looks like this. I would say yes. I would make this little graph in your books as well. I think it'll help you understand. So, in this case, we've got 2 waves. I'm not the best artist in the world, but let's pretend that both of these waves have the exact same amplitude and they have the exact same wavelength. Okay? When I say those words, do you remember them from Friday or Thursday? Okay, awesome. This thing's not working very well.
Oh, I think it's dying.
Is it? Oh, okay, that's why. I'll just keep it on. It's not tracking anymore, but
Okay.
there we go. That'll do.
Push comes to shove, I can throw my hand. I guess
Okay.
if it's not dying, never mind, shove it.
So,
Not much.
I should have drawn them different colors. But what do we expect to happen? What would this equal? What would be the resultant wave here? Any predictions?
The exact same thing.
What do you mean by the exact same thing?
You're just gonna keep repeating, going through this stuff.
Yeah, no, sorry. But we've got, this is wave 1 here. Actually, I'm going to draw it in a different color just to make it
My waves look like
look better. So purple is wave number 1. That wave is occurring. Let's pretend that another wave, wave number 2 in black, comes along. When these waves come together, as they did here, what is the wave going to look like?
Nothing, because it's
Nothing.
neutral.
Exactly. Because we have, this is the middle, we've got opposite amplitudes everywhere we go, we would not have a wave. It'd just be a flat line. Okay? So that's what occurs in this stance. If one wave was, let's try this again.
we can't erase them.
What's that?
We can't erase them.
Let's say this one was half the amplitude though. This is 1.5. Let's just go 0.5 here.
Oh, well, then we'll just generate smaller waves.
Yeah, exactly.
Big brain counter.
Big bang.
We want to redraw this now.
So what would that look like? Let's try to draw this down here. Is what we're gonna do. We're gonna try to draw this wave down here. See what that does to us. So yeah, that's not gonna work very well anymore. Oh well. How we do this is we pick a point on the chart and we can kind of graph it together. So if I pick this point right here, I'm gonna label these. So this up here, this is gonna be
Man, we don't have an erase and marker like.
You don't
Like, once this is here, it's here. It's like no like making smaller lines. Like every time you change it, it's not like I can do.
Well, don't worry about it then. Either you gotta draw a new one, or I see Rihanna drawing another one. Let's just listen for now. Don't draw this anymore. Okay? Yes, you already did? Yeah, you're good. Keep doing it then. So, what's going to happen here is we can mathematically add this. So, if this is our middle line here, we just add and subtract from that median. So, I'm going to say this is worth 1, and this is 1.5. So, this purple is 1.5. Does everybody see where I got that number from?
The line, the green
The lines,
lines.
exactly. This black one, it's just 0.5. So the resultant wave down here would just be at 1, okay? So when, at this exact point, the resultant wave would be 1. It'd be right here. Does everybody see where I got that?
Yeah.
So to get our resultant wave, what we do is we do that all over this thing. So it'd be the same thing here. If I take this point, this would be negative 1.5. Just like this was a negative 0.5, and this would be a positive 0.5. So it'd just be the exact opposite down on this side. So we'd be looking at it right about here. And if I do this about 10 times over the thing, I'll be able to get one. So we're going to do that. We're going to go over and see what it would look like. Okay? So I know that at these pots, what are these called again? When they're touching? Do we remember?
Nodes.
Nodes? Awesome. So at the nodes, it's going to be the exact same. So I can make my little marks there, make my little mark here, make my little mark here. I know that the resultant wave is going to be there. I can already see what this wave is going to look like. It's going to be something like this. Okay? So what I do when I'm working with constructive interference and destructive interference is I look at the nodes and I look at the crests and the troughs, and that's how I map out my resultant wave. Does that kind of make sense, or was that confusing to watch?
Makes sense.
It makes sense, but it was confusing to watch. It was both.
No, it makes sense.
It makes sense.
It makes no sense.
It makes no sense at all. Okay, that's okay too. What I'm going to do is I'm going to hand out this sheet. It's just working with wave interference.
Nice.
I'm going to hand it out. If you feel confident, you can start going on and working right away. If not, I'm going to do another example on the board of that, and I'm just going to kind of change the way I explain it, just so it makes a little bit more sense. But I'll hand this over first for you if you want to get started.